Hello everyone, and welcome to this second video of this series of videos of chemical nomenclature. And today we'll be talking about metallic hydrides. Metallic hydrides are formed by the combination of metal group 1, 2 or transition with hydrogen. Let's say, for example, sodium plus hydrogen, and it produces a metallic hydride that has this structure. But let's explain it deeply. First thing you have to know about metallic hydrides is that hydrogen, being part of the group 1, has an oxidation state of +1. However, in metallic hydrides, hydrogen behaves a little bit differently, because in this case, hydrogen will have an oxidation state of -1. Let's start with our reaction. Let's say that we have potassium, and this potassium is mixed with hydrogen to produce KH. First thing we have to do, remember, is to balance the charges. So potassium is from group 1 and it has an oxidation state of +1. So +1 here. And hydrogen is a hydrate. So remember that the oxidation state is going to be -1. You can see here that the charges are balanced. So this formula is neutral. But what about the masses? Let's see that here we have one atom of potassium, here we have one atom of potassium, but here we have two hydrogens. So we put the number 2 here and the products to put 2 hydrogens. Here we also have 2 atoms of potassium now because of these 2. So we go back to the reactants and we put number 2 here also. We have balanced the charges and the masses. So what's the name of this product? This is going to be named this way: potassium hydride. So what about if they say, okay, please give me the formula of calcium hydride? Remember that you put first the metal and then you put the hydrogen. Now, let's try to balance the charges. Here we have a calcium, which is in group 2. So it has an oxidation state of +2. But since we know this is a hydride, hydrogen will have an oxidation state of -1. So, since it has an oxidation state of -1, so we have to cross the charges. Here we have a 1, so we don't have to put the 1 here, but here we have the 2. So we put the 2 here, and this is calcium hydride. What about the transition metals? Let's try to do an example with copper. Copper has 2 oxidation states. So with copper, we'll have copper +1, and we have copper +2. When we make copper react with hydrogen, we have 2 different products. In this case, we have copper and H, but here we also have copper and H. So, let's try to balance the charges. Here we have +2, here we have +1. And since it is a hydride, we'll have -1 here, and here we have -1. So, in the first one, the charges are balanced, so we don't have to cross the charges. But here, the charges are not balanced. So we need a -2 here to complete the 0. So what we do is cross the charges, and we put a 2 here. So the global 2, in this case, is going to be -2, because we have 2 atoms, times -1 is going to be -2. Now the formula is neutral. Let's try to balance the masses. We have 1 copper here, we have 1 copper here, but here we have 2 hydrogens. We put the 2 here, so now the hydrogens are balanced, and we put the 2 here, so the copper is now balanced too. In this case, we'll have that this equation is balanced. We have 1 copper here, 1 copper, and 2 hydrogens on both sides. Now, what about the names? The first one is going to be called copper hydride. And the second one is also copper hydride. But in this case, we'll need to put in parentheses the Roman number because it's a little bit confusing and we have to difference them. So in this case, it's copper 1 hydride, and the second one is copper 2 hydride. Remember that what we're putting in parentheses is the oxidation state, because it could be a little bit confusing if we only say copper hydride, because there could be 2 copper hydrides. And it's because copper has different oxidation states. Alright, thank you so much for watching this video, and in the following video, we'll be talking about hydroxides.